How to write domain using set builder notation. Have you ever wondered how to express the domain of a function in a clear and concise way? Today, we will tackle the concept of writing the domain using set builder notation. This method is especially useful when dealing with linear relationships and functions. Let's break it down step by step. To start, the domain of a function consists of all the input values, typically represented by the variable x, that make the function work. Set builder notation is a way to describe this set of values. It uses curly braces to enclose the set, a variable, and a condition that the variable must satisfy. The general format looks like this: x condition on x. This reads as the set of all such that the condition on x holds. First, identify the variable you are working with, which is usually. Next, determine the conditions that x must meet for the function to be defined. For example, if x is in the denominator, it cannot be 0, as division by 0 is undefined. Now, let's express the domain in set builder notation. You can start by stating that is a member of the real numbers. This is often written as xr, then include the conditions using inequalities or logical statements. For instance, consider the function f(x) is equal to 1/x. Here, the domain excludes is equal to 0. So, in set builder notation, we write xr x equals 0. This means all real numbers such that is not 0. Now let's look at another example. For the function f(x) is equal to square root x3, the expression under the square root must be greater than or equal to 0. Thus, we write the domain as xr x greater or equal to 3. This indicates all real numbers such that is greater than or equal to 3. If you have a function defined only on integers from 1 to 10, you would express it as xz 1 less or equal to 10. This means all integers such that is between 1 and 10, inclusive. When writing the domain in set builder notation, it is helpful to clearly state the type of numbers belongs to, whether they are real numbers, integers, or natural numbers. Use inequalities or logical conditions to describe the domain accurately. The vertical bar or colon separates the variable from the condition. Using set builder notation is particularly beneficial in algebra and graphing. It precisely describes the set of inputs for which the function is valid, aiding in understanding the behavior of linear functions and their domains. In summary, writing the domain in set builder notation involves expressing it as the set of all x values that satisfy the function's conditions. This approach makes the domain clear and mathematically precise, which is essential when studying linear relationships and graphing functions.